For this experiment, we're going to be looking at the effects of liquid nitrogen on the volume of a gas. So we're going to be cooling our gas down to a temperature of almost negative 200 degrees Celsius. So liquid nitrogen is very cold. It's very dangerous for your skin. So I'm going to be wearing protective safety glasses and safety gloves. So I have a metallic dewar here. This is just going to hold the liquid nitrogen. I'm going to pour it into the dewar. And because the dewar itself is at room temperature, it's much, much hotter than the liquid nitrogen I'm pouring into it. So at first it's going to boil very vigorously because the liquid nitrogen is going to evaporate. But eventually, once it gets cold enough, it will be able to contain it inside of this vacuum sealed chamber. And you can see as I'm doing that, I'm generating a lot of fog, and a lot of people think that must be the liquid nitrogen. It's just the air vapor that is condensing when it's getting close to the cold liquid nitrogen. So now that the liquid nitrogen is settled down, I'm going to see the effects of the volume of a gas inside of a balloon. So I have a large balloon. It's almost the same size as the vessel. How many of these balloons do you think I could fit inside of here? So if I hold it up to it, it looks like about one of them will fit in the regular volume of the vessel. So I'm going to insert it in the liquid nitrogen and see the effect on the volume. This is called Charles' law. Charles' law relates the volume of a gas to the temperature. So you can hear as the balloon is getting colder, it gets brittle, but we also see a change in the volume. So I can fit this entire balloon inside of the liquid nitrogen. All of the volume of the gas has decreased because I decreased the temperature. So I could actually probably fit all of the balloons that I have inside of here. The volume of the balloon itself doesn't matter. It's the volume at the liquid nitrogen temperature. So this one's a good example. You can see how flat it is on the inside. So I now have 5 balloons inside the liquid nitrogen. We're going to see what happens when we take them out of the liquid nitrogen. So you can hear it crinkling. When we return the temperature back to normal, you can see that the volume of the gas returns back to normal. So as this balloon warms up, we see that we get all of the volume of the gas back. In this experiment, we're going to see what would happen if we put something organic, meaning something like my finger, inside of liquid nitrogen. So in place of my finger, I'm going to be using this Tygon tubing. It's a rubber type of tubing. I'm going to insert that in the liquid nitrogen and let it cool thoroughly. I'm also going to take this rubber racquetball, which is very bouncy, and we're going to insert that in the liquid nitrogen. I want to make sure each of these gets cold enough so that they are the same temperature as the liquid nitrogen. So the problem with something being extremely cold and putting your finger into it is the cells that your body is made up of are mostly water. So they are going to freeze as soon as they get into the liquid nitrogen. When they do that, they form ice crystals. And these ice crystals are going to break the cell walls. So you're actually going to destroy these cells, and that's why if you've ever taken fruit and frozen it and then thawed it out again, it gets really mushy. All of the cell walls have been broken whenever you did the freezing process. So we are going to lose the elasticity of our skin, and it becomes very brittle. Just like the balloons, it could possibly break if it's too cold. So I'm going to be using my hammer, and I'm going to see what happens to my pseudo finger And you can hear that it shattered completely. So I've lost all the elasticity of that rubber tubing, and I end up with a very brittle substance. So I don't ever want to stick my finger inside of the liquid nitrogen. And you can hear the ball. It doesn't sound bouncy anymore. It sounds really hard. So we'll see what happens through the ball. It also has lost its elasticity. So we have completely broken it apart. And many students will say, oh, well, since you've broken the ball apart, it's lost all of its elasticity, but like the balloons, it can regain elasticity. So once it warms up to room temperature, we're going to find that it is nice and flexible again. So I have a piece here that I've warmed up in my hand. So you can tell by the color that it is different. The piece that is still cold has frost all along the outside. It's freezing the air vapor around it. The piece that I've warmed up in my hands is now returned to its flexible state. So this is a reversible process for some things, but for your body, for cells, once that cell wall is broken, it cannot be repaired. In this experiment, I'm going to make my own personal air conditioning. So I have a thermos. It has water inside, although you can't really see it. I'm going to add liquid nitrogen to it. And you can see all of the nice fog that I've generated doing that. So I've got a really humid day here today. I'm condensing the water vapor that's in the air, and I am forcing it out through this tiny hole. So I can give myself a nice personal air conditioning vent. This is something I like to do for a demo on really hot summer days. And my plume's starting to die a little bit, so if I give it a shake, we get some of those ice crystals moving around, and we get some more of the liquid water interacting with the liquid nitrogen, which is causing the fog. So in this experiment, we're going to be comparing the bouncy ball, which you can see bounces very well at room temperature, to the banana. So both of these are going to freeze in the liquid nitrogen, and we're going to see that they have different properties. The ball is hollow inside, so it is going to shatter because the rubber is too cold. The banana has solid inside, so it actually will get very hard depending on how much you cool it, and we can use it as a hammer. So we have a nail that's inserted in this wood block, and you can see that it's easy to remove at first. We're going to hammer that in. With the banana, and now it's hard to pull it out. So we can use a banana as a hammer if it's frozen in liquid nitrogen. In this last demonstration, we're going to look at the effects of liquid nitrogen on flowers. So just like our fingers, when we cool this down, they're going to make ice crystals that break the cell walls. And so these petals become very brittle.